Welcome back to the Code Wolf. Today we're going to explore one of the simplest possible ways to set up and use Stable Diffusion locally on your computer. Stable Diffusion is a powerful image generation AI model, and it can be used for all kinds of things, such as creating your own stock photos. We'll see how to interact with Stable Diffusion using a free tool called WebUI, which provides a friendly local interface right in your web browser. Now, generating images locally is often preferable to using cloud services because you can generate an unlimited number of images for free, essentially, sometimes with similar quality results and much faster performance if you have a powerful GPU. We'll look at all these concepts more later, but for now, let's see how to get our model set up and running. Please consider subscribing to the channel for plenty more coding, cloud, and AI videos. We're almost at 4,000 subscribers, and I could really use your support. There's plenty more content to come. Now, I do want to mention upfront that really the main requirement for this video is that you're following along on a computer that does have a dedicated graphics card. You can, of course, try without it, but you might see some really slow results, or it may not work at all. Local AI processing and image generation is pretty resource intensive, so you'll want to make sure that's available. It doesn't necessarily have to be a NVIDIA card like what we see here, but the 30 and 40 series are really good for this type of work. So for our purposes, the first real step here is to install Python. And for this, you're really going to want Python 3.10.6, and I'll include all of these specific links in the description. But this version is required for the WebUI that we're going to be using with Stable Diffusion, and there's certain dependencies that are tied to this version, so just make sure you install this. As far as I know, Python is fairly friendly to having multiple versions of Python installed on your computer, so even if you already have Python, go ahead and still install this specific version. So if we scroll down here, we can see those different versions. I'll pick Windows 64-bit for my machine and give that a second to download. And then let's open that to install. And make sure you click this Add Python to Path, and that'll just make it widely available through the command prompt and things like that. So let's click Install and just give that a second to finish. Okay, so it looks like that was successful, so we can close out of here. And then if you want, you can just open up a terminal, and I'll zoom in here. And you can make sure that installed properly by just typing Python, and sure enough, it'll say Python 3.10.6. So we're good to go from that perspective. So the next step is to actually go out and get the Stable Diffusion model. So that's available on Hugging Face, which is an AI community, as it says here. And this platform basically focuses on models, which is what we're concerned with, so different AI models. Then there's spaces to actually host or work with those models. And then there's data sets that you can use for like fine tuning or training and things like that. So Hugging Face is kind of just this huge AI platform and community. But right now we're just concerned about models. So let's just click on models, and then we can say Stable Diffusion, just run a search for that. And we want to start with this Stable Diffusion Base 1.0. As you can see, there are plenty of other variations of Stable Diffusion. So as you get comfortable with this process, you can certainly look at those as well. But let's just start with this base model for the moment. So on this page, it'll give you all kinds of information about Stable Diffusion, and you can see some different pictures here that you can create with this and so on. So feel free to read through this if you want to know more about the model and kind of what's going on here. But just to get started, we can go over to Files and Versions, and this is where we can download the base model. And just grab this one right here. You don't have to worry about the other versions. So I'll click download, and this model actually is pretty sizable. This is about 7 gigabytes. So depending on your internet, that might take a minute, but just give that a moment to finish. Like I said, there's just a few different downloads and installs to get this working, but it's really not too bad. So let's just give that a moment to complete. All right, so once your model finishes downloading, the last thing that we have to pull down here is this WebUI. So this is the tool we'll be using to interact with Stable Diffusion. And this is just a standard GitHub repo here. So you can kind of scroll through and look at the README if you want to know more and see what's going on here. So for now, let's just worry about pulling this down onto our computer. So let's copy this Git URL. As a quick side note, if you don't have Git installed or you're not familiar with Git, you can ignore the Git clone step in this video and just download this zip file and then extract that to an empty folder on your computer. And that'll work just as well for our purposes. And then inside of a folder here, I'll open up a terminal and zoom in here. And then we can say git clone, to bring down that WebUI. This project isn't too large in file size, but just give that a second. And it looks like that completed successfully. So if we look at our folder, you can see that pulled down the entire GitHub project. Now, if you look closely here, you'll notice there's a folder called models. And if we navigate down into that, there's a subfolder in here called Stable Diffusion. So there's kind of a placeholder folder here for us to put models into. So you can see there's even a text file in here that says put Stable Diffusion checkpoints here. And so this is where we can copy in that model that we downloaded from Hugging Face. So I'm just going to copy that over from my downloads file. And there it is, just plop it there right in the models folder. So now let's go back up to our root. And there's actually a setup script file in here we want to run that will take care of installing all of the necessary dependencies and packages and set up some configurations for us in this project, and then it will launch that, and we can start to work with Stable Diffusion in the browser. So let's go back to our terminal, and I'm just going to navigate down into this Stable Diffusion WebUI directory that was cloned. So now our terminal here points to our main root folder here. And the script file we want to run is called webui-user.bat. So I'm going to hit enter to run that. And that's going to take some time and use pip to install packages and set up some configurations and take care of all kinds of things for you. I've actually already run this command, so it completes really quickly for me. But if it's your first time running it, it will take several minutes. So just let that run to completion, and then it will auto launch this browser window for us that we can use to start messing around with Stable Diffusion. All right, so now let's look at what we can actually do with this user interface. So along the top here, we have several different tabs. In this video, we're going to look at the first three and cover kind of the most common use cases for Stable Diffusion. And so let's start on this first tab. In the top half here, we have kind of our prompt area. So we can enter in text prompts to generate images and click the generate button to make that happen over on the right. And then in the lower half, we have kind of our configuration settings. So like our width and our height, and we'll look at all this more in a second. But let's start with a prompt here. And you can actually write very detailed prompts here. In fact, that often helps a lot if you provide those kinds of details. So for our first prompt, let's say something like a realistic portrait of a futuristic alien wearing armor, or something like that. And then let's click generate. And that's going to create a 512 by 512 image. And there's our alien down here. And let's actually make this a little bit bigger. So I'll say 1024. And I don't really like this result, so I'll just tell it to generate again. And that's a little bit more interesting here. So now we have this alien down here. And what's nice about running this locally is that you can just keep clicking generate to get some really interesting results. So I think this one's probably the coolest one so far. And you can click on that to see full size. And it's actually a pretty detailed image. There's even some simulated reflections in the eyes that don't really make sense for the background. But still, this is a really high quality image, and it's pretty cool that we're able to just generate that instantly. And if you want to create a batch of images all at once, we could boost this up to 4 or something. And now when I click generate, it's going to create 4 different images all at once, and then we can kind of click through them and decide which ones we like best. Now, the speed of this, again, will vary a lot depending on your GPU. I'm lucky enough to be using an RTX 4090 here, which is a really powerful graphics card. So this does move along pretty quickly, actually faster than the cloud in a lot of scenarios. But there's our results, and you can kind of click through those and decide which one you like. So I think that's kind of cool. But back up in our prompt, you can really type anything here. So I could say something like an old Mercedes sitting in the rain outside of a government building. So some kind of really moody cinematic picture here. So let's see what it comes up with here. So there's some results that start to trickle through. And Stable Diffusion can be a bit hit or miss with some things. So we'll see if the structure of the car is proper. And if you're creating humans, you'll want to pay attention to how many fingers they have or what their teeth look like and things like that. Sometimes you can get some pretty strange results. But for the most part, these actually look pretty good. So that's kind of a cool image. And it's amazing that this was able to just generate this instantly. Like, I think this is really interesting stuff. So let's look at a few other examples here. So let's say something like a photo or a stock photo of a cupcake with white frosting and sprinkles. And we're going to build off of this image for a few different things here. So let's see what it comes up with in our batch of cupcakes, pun intended. So our GPU is hard at work here, creating some cupcakes, and these look pretty good so far. But I just want kind of an isolated cupcake that we'll use for some other examples here. So that'll wrap up in just a second. And I kind of like this result here. This frosting looks a little strange. I don't really want this stuff in the background. This one's nice, but I don't really like the angle. So let's go with this. This looks like a nice stock photo cupcake, but go ahead and play with other prompts if you want to. But I'm going to click this Send Image and Generation Parameters to Image tab. And so now we jump over to this Image to Image tab. So we started on Text to Image. And so this takes a text prompt and creates an image. But now over on this Image to Image tab, we can actually use an image to manipulate the new image that will be generated. So this will kind of combine our prompt with this image that was sent over. But what's interesting is that down here we have some new settings. So we still have our width and our height and our batch count and all that, but we have this noise strength as well. And I'm going to dial this all the way down to 0 for now to see what happens. So let's just leave our prompt. Let's just leave everything as is. And I'm going to create a batch count of 3. And then back up here, I'll hit generate. I'm kind of zoomed in here so you can see this better. So the UI is a little awkward here. But you'll see it created 3 identical copies of our original image. And that's because this noise strength essentially influences how much of the original image comes through or is used in kind of the underlying source for generating the new image. By setting this to 0, it's kind of counterintuitive, but this is essentially saying keep the full original image. So if we bump this all the way up to 1, now if we generate images, we should get some images that are sort of conceptually similar, but are also a little bit different because it's going to start applying its own changes and creativity to them. So we'll see these cupcakes coming through, and notice how they're kind of similar angles and similar photos, but they all have kind of some difference to them. So for example, this one is a darker kind of muffin tin down here, and the sprinkles are different on all of them. So it's starting to take some creativity with this image. And of course, you can dial this back down to 0.5 or 0.6. And if you run it again, it'll create new images, but they'll be a little bit closer to the original because that noising level is lower. So you can see these are actually very similar, but not identical. So this one has fewer sprinkles. This one has a lot of sprinkles, but they're all pretty similar still to the original because the noising strength is sort of halfway in between. And of course, this is a pretty simple example with our cupcake, but if we were to go back and maybe go back to our alien example, so if we say a futuristic warrior alien or something like that, a realistic portrait, I just want to keep these pretty high quality images here. So first we'll see what this comes up with. And we're still getting some similar results to what we had before. But when we send this to the image to image tab, it's going to be able to generate kind of new variations of this alien based on our noising level. So if you like a result, you don't necessarily have to start over. You can just kind of start tweaking that image. So this guy's kind of crazy. These are all pretty intense. But let's just grab this guy. So that's sort of cool. And we'll send that over to image. And now if we set our noising strength all the way up to 1 and we say generate again, this should give us kind of different variations of a similar style or idea of this alien. So you can see these all kind of come through with sort of a similar angle, a similar aesthetic, but they are different aliens. So it's kind of interesting. It's actually really interesting in this case. They're all very similar, but also kind of different. If we dial this down to 0.25, now when we click generate, they should be much closer to the original. So let's see what this comes up with after a few seconds here. And there it is. So these are actually really similar. We'll probably want to bump this up a little bit more, maybe something like 0.56, and just run that one more time to see what this comes up with. So just go ahead and play around with this stuff. It's pretty interesting. You can see now we're getting aliens that are sort of in between those creative ones and this original one, but they all look very similar, just with a little bit different structures and faces here. Now, the last thing I want to show you is something that I think is actually really cool. You can use this tool for upscaling. So this is a really common requirement in different multimedia projects, or if you're doing a web project or something like that, where you might have a low resolution image and you want to create kind of a giant version of it without losing quality and such. So if I were to click here, and I'm going to open up this screenshot of an older Nintendo game. So this image, so I've got a lot of windows going on here, but this image is 400 by 240 essentially. So this is a very small image. But what if I want this same picture much bigger while maintaining the quality and art styles? So on this page, you just have to upload your image like we did already. And then you'll want to pick an upscaler. So there's different options here. These are sort of different algorithms or techniques for upscaling. And I've found that this Swin IR 4X one works pretty well. You can kind of just play around with them and see which one gives you the best results. But let's say that we want to resize 4 times its original size. And you can also scale to specific dimensions, but I kind of like just this multiplier. So the new image will be 4 times bigger. And so let's run this. And if I click on this, you can see now we get this giant image, and it's for the most part maintained sort of the aesthetic and quality of the original. They look very close. And so if we open this in Chrome, that'll tell us that it's 1592 by 960 resolution, which is about 4 times our original image. So again, if we bring this back, much smaller, but it's multiplied those dimensions out for us. And now we get this nice image. So if you ever need to upscale something, this can be a great tool. In a lot of cases, this can perform beyond what you'd see with a normal scale tool that you might see in like Photoshop or something like that. This can actually kind of reconstruct the image using an AI model, which is pretty cool. All right, so there's one other topic I want to talk about, and that's to kind of show a comparison between a cloud service version of this and what we were doing locally. So I have a DALL-E 3 model deployed out in Azure, and DALL-E is great, but there are some inherent limitations or considerations when you're running this in the cloud. You have to think about things like what is your provisioned capacity and things like that. So you can see I've entered in a similar prompt here. So we're going to try and request our cupcake again with white frosting. And then I have another tab with our futuristic alien and so on. So I'm going to submit 3 requests for our alien, and then I'll switch back to our cupcake and submit requests for this. But as I keep submitting these requests, we'll probably end up with some kind of error about provision throughput. Supposedly with what I've deployed here, I can only request 6 images per minute. And you can see that I'm already getting rate limit exceptions here because I've just requested way too many images. So you can see our 6 images did come through pretty quickly. I would say that was roughly the same as what we were seeing locally, maybe slightly slower. I don't know. I'd have to time that. But we get some similar results. However, what I think is interesting here is that I actually prefer the results that we saw in Stable Diffusion. So although these look nice, they're still sort of like a cartoony or generated looking images, even though I specifically said realistic stock photo. I wouldn't call any of these all that realistic, maybe these ones on the right, but they're not quite as good as what we saw with Stable Diffusion. And down here, these aliens do look good, but they're still a little bit more on the cartoony side. So this is one of those things where you'll kind of want to play around with this and see if you can get it to actually create those realistic images. Otherwise, you might have to choose a different model. If you really research image generation, different models do excel at different things. So some models are better at realistic images or humans, or they've been fine-tuned for certain things. And so DALL-E is great, but sometimes I find limitations with this that other models handle a little bit better. And of course, since we hit our threshold, that means we have to wait until our minute is up to request more images. So we can probably request another one at this point. But when we're running locally, we can essentially tell our GPU to just crank away all day at generating images, and we never have to worry about these kinds of thresholds. You can, of course, usually request or deploy more capacity, but that leads to further cost, whereas our local ones were free. So again, this is a nice image, but it's just not as realistic as what I would like to see. So those are just some considerations here. Obviously, all these different tools have their own strengths and weaknesses, and you just have to find the one that matches your situation the best. So thanks so much for watching. I hope you found this interesting or useful. Go ahead and play around with Stable Diffusion and see what you can come up with. And I'll try to follow up with another video that goes into some deeper topics around those Stable Diffusion configurations and maybe looking at some other models that excel at certain things. So leave a comment if there's something you'd like to see, and please hit the subscribe and like buttons, and I'll see you next time right here at the Code Wolf.